Hello and welcome to Mrs. Law's class. In this lesson, we're going to take a look at some definitions that are used in probability and then also do some simple probability questions. So our first one here is an activity that has a measurable or quantifiable results, and that is called an experiment. So an example of an experiment would be rolling 2 dice and then recording the sum. All right, the next word is one particular result of an experiment is called an outcome. So let's say that we roll the 2 dice, then rolling a sum of 5 would be an outcome. When we list the set of all the possible outcomes of an experiment, all of those outcomes are called the sample space. So for example, when we roll 2 dice, we could say that the sample space is equal to 2 because 1 plus 1 is 2, and then we can get all the combinations from 2 all the way to 12. So all of these sums from 2 to 12 would be considered our sample space. All right, the next is a subset of the sample space containing one or more possible outcomes of the experiment, and that is called an event. So, for example, let's say that we're looking for a specific event, and that event is that we want to roll an odd sum with 2 dice. The last definition is actually a phrase, and it means that each element of the sample space has the same chance of happening, and that is called equally likely outcomes. So an example would be rolling a single die and getting an even number or an odd number because they have an equal chance of happening. So rolling an even number or odd number on a single die. Let me show you with a different example. So let's say we have a spinner, and let's say that all 4 of these spaces are the same size. Then we have an equal chance of getting each of those numbers. So this is equally likely. On my second spinner, let's say that the spaces are still the same size, but because there are 2 2s, it is not equally likely that we will get each of the numbers since 2 occurs more often. All right, so let's now see how these definitions are actually used in probability problems. So, in an experiment with equally likely outcomes, the probability that a particular event will occur is given by the probability of an event. So we write it with a capital P for probability, and in the brackets we write down the event that we're looking for. So this is equal to the number of outcomes favorable to the event that we're looking for and we divide that by the total number of outcomes in the sample space. So the probability of an event equaling 1 will mean that the event is certain to occur. So there's a 100% chance that's going to happen. If the probability of event equals 0, that means that the event is impossible to occur. So 0% chance of happening. All right, let's take a look at some examples. So here, what is the experimental probability of rolling a 5 on a 6-sided die? Now, the only way that we know that is we actually have to carry out the experiment and then count out how many times we roll a 5. However, in question B, what is the theoretical probability of rolling a 5 on a 6-sided dice? We would say that the probability of getting a 5 is equal to 1 in 6 chances, because there's only one 5 on a 6-sided die, but there are a total of 6 numbers in the entire dice. For C, what is the probability of rolling an odd number on a 6-sided dice? We can say that the probability of the odd number is equal to 3 odd numbers, 1, 3, and 5. But there are a total, again, of 6 numbers on the dice, so there is a probability of a half. All right, let's take a look at a few other examples. Suppose one card is drawn from a deck of 52 cards, a standard deck, we should also say. What is the probability that it is a face card? All right, so the probability that it's a face card. Now, in a deck of 52 cards, 12 of the cards are face cards, so that would be 12. And there are a total of 52 cards. So it would be 12 out of 52, and we can reduce that to be 3 out of 13. Okay, next one is a red ace. So to probably getting a red ace, there are 2 red aces, the ace of diamonds and the ace of hearts, out of a total of 52 cards. So that is going to be 1 out of 26. All right, in the next example, what is the probability that in a family of 3 children, there are exactly 2 girls? Now, what we can do is we can actually write all of the possibilities down, but we want to be systematic about it. So what we're going to do is we're going to draw a tree. Now, each branch in the tree is equally likely because there's an equal chance of getting a boy or a girl. So there's equal chance of getting a boy or girl. All right, so we start off with the first child, and it can be a boy or girl. And then we're going to branch out. If the first child's a boy, we can say that the second child can be a boy or a girl. If the first child's a girl, we can say that it could be a boy or a girl. Now, if the first child's a boy, the second child's a boy, the third one can again be boy or girl. And the same with each of the other branches. So from here, we can see that our sample space is B, B, B. And then we follow the second branch, B, B, G. So B, 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 and then we have B, B, G going down here. And then we can go down the second branch now. So B, G, B. And we continue in the systematic way to list all of our outcomes. And then we have G, B, B, G, B, G, 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 B, and G, G, G. So from here, we can see that the probability of exactly 2 girls is equal to 3, because we have 2 girls here, 2 girls here, and also 2 girls there. And there are a total of 8 possible outcomes. So the probability is 3 out of 8. All right, the last one I want to show you is when we roll 2 dice, I want you to find the probability of getting a sum of 4. Now, some questions are a little bit different. So to do this, we're going to use a sums table. So I'm going to list the numbers 1 to 6 vertically and also 1 to 6 horizontally on my table. And then we're going to add up all of these numbers to create our sums chart. So we get 2, 3, 4, 5, 6, and 7. So you can also do this on your own, and so just pause the video while you fill the sums chart in. All right, so from our table that I've now finished, there are a total of 6 times 6 equals 36 possible outcomes. So what is the probability that we have a sum of 4? Well, we can see that here there are 3 4s out of a total of 36, which reduces to 1 out of 12. What about a sum greater than 7? So those are all the numbers down here on our table. So we have 5 plus 4 is 9, 10, 11, 12, 13, 14, and 15. So there are 15 sums out of 36 that are greater than 7, which reduces to 5 out of 12. And then finally, what is the probability of getting a sum of 5 or 6? Those would be those numbers over here. And there's 4 5s and 5 6s, so there are a total of 9 sums out of 36, and that gives us 1/4. And that's how we do some simple probability questions.